And we will go over the database redundancy. Okay, so this is very important. We provide redundancy not just for relational databases, for NoSQL databases as well. Actually, it's more common for NoSQL databases to have the database redundancy. You think about MongoDB, right? Usually 3 replicas. You think about some other NoSQL databases, it's pretty common for a NoSQL database to have redundancy. Simply speaking, multiple copies of the database. Even when a database is sharded, we still have replication. We do replication to get multiple copies of the database, right? With relational databases, we can do the same thing. So we will go over different options for providing the redundancy, database redundancy. Make this larger, easier for your eyes. Log shipping. Okay, so log shipping. This started with the relational databases many years ago. So you look at the architecture, make this smaller. Smaller, we can see better the whole picture. Smaller. Okay, so you have your primary database here. So this is like your production database, right? Your primary database. Then you have secondary databases at remote locations for various purposes, maybe for disaster recovery, maybe for putting a copy of the database close to a certain group of users to make reporting more efficient, right? Data locality. So there are many other use cases or business reasons for providing the redundancy. So generally speaking, you provide redundancy to increase the dependability of your database and availability of the data. You can use log shipping. So the concept is very simple. That's the reason why it started probably 15, 20 years ago. Okay. So you will back up changes at the primary database. The changes are usually stored in a log. We call that a transaction log, right? So you have changes since the last checkpoint stored in a log, transaction log. In the transaction log, you just have a bunch of SQL commands, like, insert, update, delete, whatever, right? And you will periodically send the changes in a log from your primary database to a share. And this share can be accessed by all of your secondary databases. So your secondary databases will be configured. Therefore, periodically, they will come here to get the changes in a log. And then they will take the log. Remember, in the log, you have insert, update, delete, right? You will apply the changes to secondary databases to sync the secondary databases with the primary database. So it's very simple to say this in a generic way. So what we are talking about is a very generic approach. But in industry, there are so many variations, so many different implementations related to this. So let's go over some of the variations. For example, you can have a data refresh interval every day. Okay, I've seen company doing that every night. Then every night there was a large transaction log to be picked up by secondary databases, and then secondary databases are applied to those changes to them to stay in sync with the primary database. Or you can do the data refresh every 10 minutes. So every 10 minutes, there will be a new transaction log to be applied to secondary databases. Or you can even do the data refresh more frequently. Okay. Event-driven. So think about event-driven. When we say the data refresh is event-driven for NoSQL databases, actually those events are not synchronous. They are asynchronous. So one variation is that you have a message queue, right? So for SQL Server, there's a message broker, or you have all sorts of message queues. It's just a queue, first in, first. It's just a queue, right? It's just a queue. Your requests are put in the queue, and then your secondary databases will pick up the change from the queue. You can do event-driven, like, every change can be replicated, can be sent to the secondary databases immediately. So that's just how you configure it, okay? But you will go through a share. That share may be a queue. So NoSQL databases do that a lot. On the surface, you think it's real-time, synchronous, but it's not, okay? Because they have eventual data consistency. So it's asynchronous, but the data refresh is near real time, not synchronous, not real time. But the data refresh intervals can be much longer. It really depends on your configuration. And you can have a share, you can have a message queue, you can have one copy of the primary database, 2 copies of the secondary databases, or 5 copies, depending on your requirements. And this approach is very cost effective. The architecture is not that complicated, very cost effective, very dependable. Okay. Well, very good, right? Not expensive, but very dependable because you have logs that you can trace back. And this is an implementation that I took from previous work. So the customer had 2 very large web farms at 2 different data centers. And then we used log shipping to sync the data between these 2 farms. And keep in mind, when we do log shipping, you ship the changes from one farm to another. You ship only the data, right? Because you cannot ship the environment configuration parameters because those are environment specific. So you just ship the data. And another thing we do on a regular basis is the database snapshots. So there is a common misunderstanding about the database snapshots. A lot of people think, well, as long as I have a database snapshot, I can always recover my database. I won't lose any data because I have a snapshot. That's totally wrong, okay? Especially if you are going to be a cloud engineer, you want to make sure you have a copy of the complete data. Usually it's a backup or a replica. You do not just have a snapshot because the snapshot only has the changes since the last checkpoint. For old data, you still need to go back to your old database. or the backup, whatever, right? So a snapshot has only recent changes. You cannot count on a snapshot for recovering all of your data. Actually, if you do not have the base database, your snapshot is useless. Very common very common misunderstanding, especially for some cloud engineers. Okay, you cannot count on a snapshot for recovering your data. You don't have the base database, the base backup, your snapshots are useless. So in SQL, it's very easy to create a snapshot and go back to a snapshot. Remember, a snapshot just has the changes up to that checkpoint. You don't have complete data in the snapshot. And this is also very interesting. So this is still being used in industry. We have several data centers and databases that we need to keep for various purposes, for high availability, dependability, or data locality, disaster recovery, right? So you have databases at the same data center. If you have databases close to each other, you can do synchronous mirroring. And this is real time, real time, okay, real time. But with a remote location, you can just do log shipping, what we just went over. Then you can have multiple remote locations. So you do mirroring at the same data center and log shipping with a remote data center. And you can have servers for management purposes to monitor the data sync. But this is kind of old technology. So in industry, we have newer technologies. So you have a cluster, a virtual cluster, which covers multiple data centers. So in this example, you have two data centers, the primary data center and a secondary data center. But you have a large virtual network, virtual cluster covering both data centers. At the same physical data center, you can do synchronous. Okay, but with a remote data center, you do a synchronous data sync because of the distance. You have latency because of the long distance. But you have whole thing treated as a virtual server, a virtual cluster. We call this the availability group. You may see different terms, but same implementation, same architecture. To your users and to your application, they will go through a router, a listener, or whatever, the front end, a front end component of the cluster. They will just see one virtual computer and one virtual database. But behind the scenes, you can do all sorts of load balancing, disaster recovery, and many other things. Okay, very interesting. So this is a common architecture. You may see different variations offered by different vendors, but the underlying architectural concepts are all the same.